I learned is this tech can cut costs for cloud GPU 3 to 7 times.
Tell me more. Welcome to the Beyond CUDA podcast. I'm your host, Jeff Tatarchuk, co-founder of TensorWave, an AI cloud built exclusively on the latest and greatest AMD GPUs for all your training and inference needs. Today, we're excited to have on the show Andrei Chepstov, who is the founder and CEO of dstack, an open source orchestration platform built for AI workloads as flexible and is a flexible alternative to Kubernetes and Slurm. Previously at JetBrains for over a decade, he's helped shape tools like PyCharm and much more. Andrei now focuses on redefining AI infrastructure truly beyond the CUDA ecosystem. Andrei, man, good to have you on the show.
Hi, Jeff. Thanks for having me.
Well, man, I know we've been friends for a little while now, and seeing all the exciting stuff that you're doing, building on top of the open source ecosystem, and there's been a lot of momentum as you've been growing dstack. But I want to start from the very beginning. I want to start with, how did you get your interest in tech? Like, even go way before the very beginning. Like, what made you decide to go down this path?
Right. I think the first episode was for like a certain way we got access to a very back then, like it was I guess like 10 or something. We got access to one of those like personal computers, and it was like very early versions. Like I right now wouldn't even like bring the name, and it was basically black screen, right? It was basic DOS. You turn on. There was no programs except basic there, and everything would like you could have there was either you program it or of course you bring something on the like on this disk. It wasn't even floppy disk, it was something with what was before. And my brother actually once came from school. He's like 4 years older than me, and then he thought, actually we're gonna have some fun today. We'll program it this thing to actually solve equations. I was like, what are you talking about? Like, so I actually remember that moment, and I think since then I got some kind of an attachment to programming, and it influenced a lot. Of course, like later I had more modern computer, but since then I was very much into programming.
Nice. And tell us about the journey of your time at JetBrains.
Right. Yeah. So JetBrains for me, it has special place in my heart.
And for
Like
those that don't know, tell us what JetBrains is. And
yes, exactly. So I think that was during my uni time, when I got my first job as a software engineer, mostly building like enterprise software for different kind of like companies that want to automate the business process. And like I remember, I mean, before that I was mostly into C++, and once I started working more on this business software, I uh, got acquainted with like a C++ builder, and then eventually .NET, and then a friend of mine once came to me and said, "Hey, why aren't you using Java?" I'm like, "What is Java?" And he's like, "It's like .NET but so much better, and people love it." And back then I was like quite um, let's say impressed by what Microsoft was doing with Visual Studio Online, and back then I got this first idea of the productivity. I don't know whether you remember or not. In the IDE, it like the feature called auto completion. It basically it helps you write code. Probably right now half of the people who are listening to us like, what are you talking about? And then I really liked what Microsoft was doing with Visual Studio. But then a friend of mine showed me IntelliJ. IntelliJ, basically an IDE written in Java for Java, And I remember that moment when I launched it, and it said on the logo like "develop with pleasure." I'm like, hmm, that sounds interesting. So that, and then like he told me about, hey, like, did you know about refactorings? I'm like, what refactorings? And then of course I read articles about that, and so that's how it started. And I fell in love with JetBrains, with an idea of productivity. Before that, I mean, of course, you really enjoy coding as a programmer, and I'm really curious how this process is changing right now with this vibe coding and at all. I think it's getting even better probably, but that's how I got familiar with JetBrains. And at certain point, a friend of mine who was working there invited me into the office, and then I got this chance to join them, to actually switch from software engineering to product management, like marketing. And for me, it was a career switch entirely. But for such positions, JetBrains only hire technical people. So I actually had the chance to still enjoy programming.
Yeah. I love it, man. You definitely are an amazing marketer. I've seen what you've done with dstack and how you've built such great brand awareness and partnerships and uh, co-marketing material. You're crushing it. Um, Talk about some of the key lessons that you learned during your time at JetBrains that shaped how you're currently building dstack today. What were some of the big pivotal moments for you then?
Yeah, that's a hard question to answer. Because for me, joining JetBrains was a lot of pressure, because before that, I was mostly working with engineering teams, and joining JetBrains, you immediately start to be like developer facing. You basically start to interact with developers who use the tool, so it's totally different experience. And you are not only following the plan you internally came with, but you are responsible for also taking their feedback from the community. And also JetBrains is one of these companies that used to, and then still to a big extent, it is still the case now, pretty flat. Means that pretty zero, like very thin layer of management. If you work on something, it's most likely that you came up yourself with that idea. And of course that taught me a lot about um, how to source ideas, and then how to bring them to the development team, and then also how to speak with developers to find ways to get this done, like with what sometimes users ask for very strange things. And the product evolves thanks to this conversations with both parties, like users and engineering team. I think that was main. I don't even call it a lesson. It's more kind of an experience. But that's a highlight, of course, because like no bottom top down plans or like ideas. You search for ideas within the community.
Mm, I love that. I love that. A lot of people, they think that, they just need to go out and build a company. But if you go work for another company, you can take those lessons like with JetBrains, which is a very community focused, developer focused, engineering first, flat organization, and you could then take that culture into your next venture. Talk about how the idea for dstack came about. When was the epiphany moment for you where you're like, hey, I want to go all in on this?
I guess there were a couple of moments. First one, in time I was a PM for PyCharm, and I decided to actually like become a PM for PyCharm because um, we at JetBrains also started to see how like this data aspect changed the way software is being built. JetBrains come from this classical software development where it's just about code, right? But then with this rise of big data, data engineering became a thing, data science became a thing, machine learning became a thing, and I was fascinated by the whole evolution, let's say, or now we probably now see it as more kind of a revolution. But it was interesting to me, and that's why I thought I want to build something for those for this new wave of developers. And I was in time responsible for bringing notebooks into PyCharm, which is a we probably need to have another podcast about just about that.
And for those that don't know, what is PyCharm?
Right. PyCharm, JetBrains, like probably some of you know about like at least one ID by JetBrains. JetBrains has many IDs, um, um, but PyCharm is a one of their products within this family, specifically for Python developers. PyCharm is an ID for anyone who is using Python, means data scientists, like data engineers, ML engineers. The challenge was to bring this notebook experience, because notebook experience is a little different from a classical editor, code editor, because it involved experimentation, it involved the interactivity and all of those things. And that's how I got into a situation where I interview a lot of ML teams. I mean, of course, I talk to like data engineers, like data scientists, but eventually ML engineers, and that's when I learned how challenging this infrastructure management is. And that was before, of course, the LLM thing. And the challenge got so much bigger today, and so much more companies now actually have to deal with that. You can imagine. But back then, I was surprised because I looked at what ML teams did, and I guess a lot of ML teams still do it today. You need a platform to automate so many things, and because there's no like a tool out there that would do that, like for example, if we want to like manage containers, like we build containers, we have Docker. If we want to like provision like cloud infrastructure, we have Terraform. If we want to automate, let's say, deployments across clouds, we have Kubernetes. But when it come to like building an ML platform, uh, any none of these tools actually would do what you want without you making a very big effort into automating this. And every day this gets better, it gets easier, and we are still so far from where we want to be. So you can imagine that how big is the challenge. And back then I thought, Kubernetes is there, and I mean it like in the ideal world Kubernetes would just solve this. uh, but later I learned that Kubernetes was very rarely a solution to that. And many companies had to build internal platforms, had to fill what I today call gaps left by Kubernetes. Which means that of course you can do that with Kubernetes, and Kubernetes is going to stay that layer, because so much was invested into that by hyperscalers. And now we also see that now clouds also invest heavily into Kubernetes. So Kubernetes is here to stay. But Kubernetes is already existing thing, so you cannot really change how it works. That's why everyone now have to build on top of that as just a layer under the hood. And with this deck, like I thought, mm, what if we focus entirely on ML, and if we started Kubernetes project like again, what would we do differently? Of course, the situation is slightly different. Like we're not Google, and probably Google is not using Kubernetes either. So It's a different situation, but we are on this mission to redefine. So basically, rebuild this from scratch without taking same compromises that Kubernetes did, and then try to solve some of the problems that Kubernetes has. Like for example, um, one thing that I think uh, can significantly be improved is the abstraction layer. With Kubernetes, you have this low level concepts or concepts that were tailored um, for deployment. Um, and For example, when it comes to like efficient training, or is it training of large language models? Uh, we have to use something on top of Kubernetes. Something. Nobody knows what this something should be. Just something, some software. Uh, and our idea is to simplify that and make very fine grain abstractions here, so anyone can build on it, regardless of the vendor, right? Regardless of the cloud provider, or like which models or
Yeah.
um,
You mentioned that there were some gaps or holes in Kubernetes. What are some of those gaps and holes that you or the developer community you've been speaking to have identified, and what is dstack doing to address some of those gaps?
yeah, one which I partly mentioned, it is the abstraction uh, level. um, if you are an ML engineer, you need abstractions that, like, I mean, imagine that you are an ML engineer, but you have to deal with pods. What do you do with pods? Like, isn't like you want to train the model? Like, how many pods you need to train?
Right.
It's an abstraction, and then that's one. Um, um, or also their um, the the thing is, in order to make Kubernetes work really well with GPU, you have to invest a lot of, like, you should make a very big effort. NVIDIA is doing this effort today. AMD is doing this effort today. Other companies contribute to this. It's a very slow process, and one of the reasons why it's so slow is because the complexity of Kubernetes. If Kubernetes wasn't that complex, the process was so much easier. Just look at how VLLM or SGLang or others, they are at a very short periods of time, they were able to improve the efficiency and radically simplify their running the process of, running inference, because they didn't have to deal with that level of complexity. Imagine that instead of building it like aside, they had to rework one of the existing projects. Um, uh, I guess that's a second big problem that Kubernetes has. So Kubernetes is an amazing project. I really have to say it, and I do believe that Kubernetes is here to stay, regardless, despite of all these problems. Um, but but we need to radically reduce the level of complexity in order to solve it for ML engineers.
In simple terms, what problem does dstack solve for AI teams that are, you know, currently frustrated with what they're using? And is dstack a complete replacement for Kubernetes? Can you just run what you want to run using dstack and dstack alone?
First of all, this tech can run on top of Kubernetes,
Mm.
and we have multiple teams that do that. And the main reason, typically, is we already have Kubernetes, and it's never like, hey, we like Kubernetes. It's never like we like Kubernetes. We want to use it on top of Kubernetes. I never seen anyone like that. Never. Seriously, I'm not joking. It's always like our platform team says it's no way. It's either Kubernetes or it's not there, going
That's
there.
right.
That's what pushed us to. make Kubernetes first-class citizen, and ensure that this tech can run on top of Kubernetes, which is fair because Kubernetes, a lot of companies invest hugely to make it work. Is just on top of even when companies use Kubernetes, they still often lack a simple way of orchestrating ML workloads.
Mhm.
On top of Kubernetes, you still need an orchestrator. Um, so that's one. Then, but a lot more teams actually use it without Kubernetes. Some of the large teams that come and say, let's take an example, teams that actually use heavily Kubernetes, and they end up not using Kubernetes with dstack because they see the value dstack brings, if you don't plug it into Kubernetes. This can be multi-region, multi-cloud. We actually have quite many companies that use it for that purpose. Of course, not everyone is doing multi-cloud, multi-region, but this is one of the points where like of Kubernetes, that it's not easy, and you basically having a control plane. Um, there are even like companies that offer a control plane over multi Kubernetes control plane kind of thing. Teams in the end need one control plane that would simplify the orchestration. And then of course we have many companies, teams that prefer actually not using Kubernetes. They just they use the native integration, um, and there is kind of competition in that case. This tech competes with some of the features that Kubernetes has. For example, Kubernetes is a managed Kubernetes typically is able to provision clusters, and if this tech is natively integrated with cloud providers, it can do that too.
Mhm.
Some companies don't want to bring the skill set to the team to spend time on Kubernetes. They say we want to just get to the value quicker. We want to focus mostly on like models and then data, and not the infrastructures that they are looking for a streamlined um, alternative. That's why they choose this tech. But if I sum up like what this tech does, on one hand, this tech simplifies provisioning of the GPU, and it
Okay.
brings also a certain level of efficiency when it comes to provisioning, like an increasing like utilization. Like you can build even yourself that with Kubernetes, but you would have to build it or actually buy a like some kind of a platform. I know a few, uh, but um, but with this stack, even with open source version, you don't have to do that because this stack solves this. Um, and then their orchestration. So in addition to provisioning, it's orchestration. Imagine even you've provisioned already a very big cluster. So how do you efficiently utilize that? And just once again, with Kubernetes, you can have all of that, but you would need to bring these custom operators. You would need add additional logical. You would have to buy an enterprise grade platform, commercial one.
Now, do you think eventually dstack can replace Kubernetes? Is that the vision or the goal, or you always see it as something that'll be working in in connection to Kubernetes?
That's a great question. Um, and we often think of this, but in my personal view, we don't aim to replace Kubernetes. I mean, if Kubernetes did many of these things easier, we wouldn't have to do it.
That's
Um,
right.
and we certainly it's also it's not that easy, right? So you mentioned the time we spent on building partnerships, on integrations, um, um, and um, there are many players in this market, hardware service providers, um, and software providers, and of course companies of different kinds. Um, and that creates a lot of dynamics here. Kubernetes is here to stay. It's driven by cloud service providers. As I said, in the first days, it was hyperscalers. Today, it's every GPU cloud. It has to invest. It doesn't have a choice of like, no, let's not invest into Kubernetes. Okay, say goodbye to your business. Uh, it's just a must. Um, on the other hand, um, many companies need solutions. I mean, of course, everybody invests in Kubernetes, but hey, in the end, we need an easier way to manage our training. Uh, you see, basically, different players have different view into that. That's why we are able to compete with Kubernetes. And but then what I like to say about this is the idea here is not to compete with Kubernetes as a provisioner, or the main purpose here is to compete with it as an orchestrator, which means that you run on top of Kubernetes. You can run on top of Kubernetes, and I totally see the future with this tag that Kubernetes is a first class citizen. It remains first class citizen, and the integration with Kubernetes go much more tight. So I see you, and as you also mentioned, that, and even though I don't often like to maybe myself use same phrase, you said this stack is an alternative to Kubernetes and Slurm. But it is the reality. We have two tools. One is solving partly provisioning and orchestration, and another is solving orchestration. The elephant in the room here is that there are gaps. Um, that's why, yes, this stack competes with Slurm. Absolutely.
Tell us about the roadmap. When did you start dstack? What do you currently have available now, and what are you excited about the features and things that are being built out in the next 6 to 12 months?
Right. Just end of last week, we made a release with a feature that we wanted to bring long time. It's a passive GPU health checks. Uh, Probably if you are into GPU, you might probably have seen this paper by Meta um, about how they manage clusters. It was, I guess, end of last year or something like that, where they elaborated like what kind of problems they have, and you could easily, the name of the paper, I don't remember what that is, something about scaling clusters, but you can easily change the name of the paper into GPU health check, and it would make even more sense, because the paper, it elaborates on the biggest issue that you have when it comes to large model training. It's a GPU health check.
That's right. It is.
And what do you do with that? So that's why we pretty excited about this, and well, also from the paper, you can learn that it is also a part of Slurm. Um, you can have it solved to a certain extent through Slurm, and uh, of course you have to bring it to Kubernetes if you are using Kubernetes, but because this stack can be alternative to both, we want to have GPU health check natively built into this stack. And the release I mentioned, it is our first iteration, and we always work like that. We actually build releases every week. Nobody has to upgrade, but the opportunity is there, and we always start with a very rough version, and then we of course seek for feedback. So that's one is pretty cool. Passive house checks, if somebody wants to know, it's when you collect different events from your system about the GPU. In a passive mode means that you don't interrupt the workload. You're collecting it like in almost in real time. And that's great because this way you avoid running something there or detecting this from early on to ensure that your workload can um, be not affected. So it basically gives a way to mitigate that problem.
It's important.
Um, exactly, because their utilization of the cluster becomes in the end probably most important thing, because again it comes from the cost.
You gotta get the most juice out of this cluster. You gotta know how well it's performing, and if it's not performing, how to swap nodes out or swap GPUs out, and know which GPUs are failing and need to be replaced, and all that sort of thing. How big is your current team right now?
We are pretty small, so we're 7 people right now. Uh,
But you're built on
mhm.
open source, and you're building your community. Talk about why you decided to, go open source, and that process of, building and growing your open source community.
Backward looking, uh, it was um, it was not that much rational. I guess it's just the development background. Developers like open source. So
That's right.
a
Would you
funny
would you
story.
change if you can go back? If you could start over again, would you just do a closed source proprietary solution to help make orchestration easier?
I think that this can be done both ways, right? Open source, maybe somebody might not like this idea, but open source exists because non-open source exists. Um, Open source is a way to solve many problems. You can solve all problems with open source, but you can solve certain problems. So you can not deal with other problems. So that's how I personally look at it. Open source is just like, I sometimes we discuss this with somebody, and I was making this analogy of playing chess, like white and black. So somebody plays white, somebody plays black. And then next time you can change sides, right? You can change it. But as a somebody, like as a developer, as somebody coming from that background, I really like the vibe. I really like working with the community. I really like the value that open source brings, because it brings people to collaborate, right? Even without commercial, like immediate, like commercial direct reason. Of course, commercial side is also very much mixed into that, but open source, it makes it much easier to collaborate and bring different partners to even collaborate together. I guess that was the main reason. And next time, I can't really say. I wish I could say, yeah, of course, like open source, like and but in the reality, it's a complex world. It's a complex world, and in the end, we need to solve a problem, and open source and proprietary, they solve different parts of the problem.
You've been working on this for what, going on almost 2 years now?
It's actually 3 years. It is 3 years, and the first version was not open source, and only at certain point. But it was the first year where we decided to change the gear, because we were really looking for collaboration with teams that are constrained by this process of like buying software, procurement process. But the thing is that one of the reasons why this stack is open source. There are two ways, right? There are typically two ways to build it. At least two ways. One way is you build it in Meta once. Now you make it a commercial company, and we see many companies like that, actually, that came from Meta or like from some other companies. So
Mhm.
that's one playbook. Another playbook is, okay, so we didn't build that, but we know how to build development tools. So let's bring ML engineers, different teams, and build it together. So basically, kind of co-design, like bringing design partners, and that's an open source way. Um, I guess it this way.
Yeah. No, it makes sense, man. In the 3 years I've been working on this, what's the hardest technical challenge that you and your team has faced that you see is kind of if you could snap your fingers and fix this one thing, it would make life for you and make life for your users that much easier?
When I was listening to the first part of the question, I actually wanted to say that handling logs is the most difficult thing in the world I ever dealt with.
It's
Um,
a lot, man. It's a lot.
and we still face this issue. But jokes aside, um, well, the challenge is the challenge here is that this ecosystem is a moving train. It's a fast moving train. Nothing stands still. It evolves pretty quickly. And the challenge is to how to bring adoption to a standard. So that's the challenge we have, and that's why we have time like building these partnerships and collaboration in order to every day make it a little bit more of a standard. So I guess that's the challenge we are on.
What are some surprising ways you're seeing teams use dstack today that maybe you didn't anticipate when you started?
What surprised me is how they think what value is.
Mm, tell me more
Um,
about that one.
right. Um, I very often have to talk about this tag and talk why we build it and what the value is. But uh, but it was very surprising to hear how developers talk about that. How because it was like uh, like I didn't think that about this way. And what I learned is this tech can cut costs for cloud GPU like
How so? How so?
3 to 7 times.
Tell me more.
Right. Um, Again, these stories come from hyperscalers a lot. I would say with now clouds it's slightly different, but that's a different story. We have to talk about that too. But with hyperscalers is that um, uh, hyperscalers especially they um, they offer their own proprietary platforms. I mean, now it's changing a little bit here, a bit by bit, but they're mostly offering like the proprietary platforms to manage GPU workloads, and that's designed the way that you either end up not provisioning it or provisioning it and not utilizing properly. And it's just incredible how much money you spend on it. um, um, you all GPUs are expensive.
Mhm.
Cloud GPU are even more expensive if you come to think of it. And and the way you orchestrate your workloads and utilize it and switch the utilization of your clusters, your cost can vary. Like it can like if you optimize its usage, it can go down like from 7 to like 3 times. So that's one. I never thought of it. I'm like, oh, we should charge like companies more.
Absolutely.
That's one. Yeah.
So they could save 7 to 3 times more. Now, which companies? Is it is it the hyperscalers that you're saving money for? Is it the clouds, or is it the end user that is getting the money saving? Who is saving money?
That's with on demand, definitely. That's with on demand. But with reserved capacity, it's different value that teams have with this stack. It's utilization of the cluster because they're typically if you reserve clusters, you probably need to basically drive utilization. Utilization becomes the bottleneck basically. for you. It means that there, even if you tweak a little bit the efficiency of the utilization, you can squeeze it like so much more. So it works both for both, like on demand and reserved too.
What are you excited about moving forward as you've just done this most recent update? How can others, how can other people get involved in what you're doing? Who should be reaching out to you to try this? Talk to us about what you're currently excited about and how more people can get involved in dstack and try it today.
Absolutely. We there are two with the product. There are two areas where we plan improvements. One is this classical Slurm setups with lots of like machines in the cluster, and we see Slurm is a kind of a standard, right? So because it was built for HPC, and it uh, it also pretty common choice with academia, and academia becomes a part of labs. So that's why Slurm is such a thing, such a big thing. But again, it's not because everybody likes Slurm. Of course, people like Slurm. It's slightly different compared to Kubernetes. At least there are people that like Slurm. I know them. But the thing is that Slurm also has a lot of gaps there, like a lot of gaps, and it doesn't solve all the problems. And basically, you only way to you can use Slurm is on top of Kubernetes. So you basically would have to use them both together. And that's where we wanna improve dstack for exactly Slurm kind of setups. And GPU health check is just one big step towards this. um, and that's why if somebody is using Slurm and curious to see how this deck can streamline the process of the utilization of the cluster and also improve the development experience, um, uh, we would be really happy to welcome such people to come and try and give feedback and give harsh feedback as well. This is what we are looking for.
Where can they
So that
find you? Where can they find this, and where can they get access to it?
it's mostly GitHub, and this is where you can find the instructions how to build it and then how to set it up. You don't need anyone's permission to set it up, regardless of which cloud provider you use or whether you work with like uh, private cloud. Um, and of course, there's Discord to chat with well, with the team and with other users. I guess those two would be main uh, resources.
Awesome, awesome. Um, Last question that I ask all of our guests: what does Beyond CUDA mean to you?
Yeah, so I actually really like the idea, and so
There we go. Show AMD some love.
exactly. Um, I think to me, Beyond CUDA, I guess I would guess different people understand it differently. And I would guess somebody would find something bad about for example that we bring CUDA here. But for me personally, it's democratization of compute. Like, let's be honest, compute today is probably one of their most needed resources, like global planet scale. The problem is so much bigger than like anything here, and the impact it can bring is just unthinkable. It's not about like, hey, how CUDA is like better than this or how this is better than CUDA. Like, shut up. We need compute at planet scale, and let's do everything that we can do about it.
So good.
Um, that's exactly what I understand about it. Yeah.
I love it, man. Andre, I appreciate you coming on and sharing more about dstack. For those of you that are watching, follow Andre on X and dstack on X. They're very active, showcasing all the things that they're working on, all of the releases. Join the community. He's we're excited about what he's working on, and Yeah, keep going, man. Keep going.
Thank you, Jeff.